Hello students. So concerning the correction of the assignment, it was required to calculate the resultant force of two or three given forces acting on the same particle, let's say. The two forces that were given was F1 and F2. So that's why in order to solve this problem, we are going to consider the particle on which the two forces are acting to be the origin of the frame of reference. So as you can see here, I consider it to be the origin O, and I drew two perpendicular axes, the x-axis and y-axis of the reference frame. So now after resultant is F1 vector plus F2 vector. If we want to use the parallelogram method, we can consider that F resultant is the diagonal of the square whose sides are F1 vector and F2 vector. Actually, we say نحن F resultant is the diagonal of the parallelogram. But since here the angle between F1 and F2 is 90 degrees and they have equal magnitudes, 2 Newton, yani two equal consecutive sides. So directly it's clear that this parallelogram formed by F1 vector and F2 vector, having of course opposite sides equal, is actually a square. That's why here I mentioned it to be a square. So F resultant is the diagonal of the square whose sides are F1 vector and F2 vector. So by doing construction, drawing the side opposite to F2 and equal to it, parallel to it, and that equal and parallel and opposite to F1, here we get the square. So we draw the diagonal, which is F resultant. Making use of some geometric properties, for example, in order to calculate the magnitude of the resultant force, F squared, as you can see here without vector, F squared resultant is F1 squared plus F2 squared. This is according to Pythagorean if you want to apply it in this triangle, for example. Here I have to mention that your given F1 is 2 Newton, but this side is equal and opposite to F1. That's why I consider this side to be F1 and this one F2, and they are right, having 45 degree here, so this is also 45. Now F squared, which is the hypotenuse of this right triangle, is equal to F1 squared plus F2 squared. 2 squared plus 2 squared equal 4 plus 4, which is 18 Newton squared. And here we have 2 Newton all squared, so we have to square the magnitude and the unit. Newton squared. We have to do radical to square root it in order to obtain F, not squared. Usually in mathematics you say plus or minus, but here in physics, because we're considering the magnitude of a force, we reject the negative magnitude because it's not real, and we accept the positive one. So here we get 2 radical 2 Newton. And now I said previously that this is not enough. It's not enough to find the resultant magnitude. We have also to determine the angle between it and the x-axis. As you can see geometrically, having this whole one to be 90 degree, and this is a diagonal, and we know that the diagonal in a square or in a bar is the angle bisector of the base angle. So this was 90, then this one is half it's 45 degrees. So the angle between F resultant and x-axis is 45 degrees. Now considering the second case or the third case in figure 3, in which the two forces acting on the same particle were opposite forces. What do I mean by opposite forces? They are collinear, they have the same line of action, but opposite direction, one to the right, one to the left, and equal magnitude. So F resultant vector equal F1 vector plus F2 vector, but they are opposite vectors. That's why the resultant force is going to be 0, and a 0 vector could not be represented.